Check this out. I'm not a big fan of having you guys memorize a whole bunch of equations. Oh, this is number 38, by the way. I'm not a big fan of having you guys memorize a whole bunch of equations. What I like doing is just having you guys memorize a few of them. So let me show you one of them that I do want you to see, and it looks like this. All right, a squared minus b squared is equal to a plus b times a minus b. Okay? So anytime you see something squared minus something else squared, you can basically just plug it straight into this formula. You take that first thing plus the second thing, put a parentheses around it, multiply the first thing minus the second thing. If you don't believe me, FOIL this out and you'll find out that these are the same thing. Are we cool? This is called the difference of squares. Got it? And keep in mind that it's the word difference of squares. There is no such thing as the sum of squares. So a squared plus b squared, you want to know what that's equal to? A squared plus b squared. There's nothing you can do to factor this thing down. The sum of squares is not a thing. Difference of squares, there's a formula for that. Okay? Keep those in mind. The reason why I actually just did a test, I was just doing a problem and I saw this on the problem and it said 36x squared minus 49y squared, and it said factor that. And immediately I looked at that and I said, 36, that's a buzz number in my head. 36 is very important, that's 6 squared. And x squared, I know that. So this is 6x squared. And then this is 7y squared. So if I factor this, this is just 6x plus 7y times 6x minus 7y. I don't even need to think about it. I can just use that formula. Okay? So this formula is good for you to know. And it's not even that hard. Now, there is something called the difference of cubes and the sum of cubes. And that's a little bit different. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. I think that's the end. Yeah. And then the difference of, or the sum of cubes, a cubed plus b cubed is equal to a plus b times a squared plus minus ab plus b squared. All right. And you're asking yourselves, Mr. Dalday, why didn't you teach us these equations? And Bradley's saying, I don't even want to memorize them. I have a lot of equations already in my head. And you're saying, why didn't you teach us this, the difference of cubes and the sum of cubes? I'll tell you why. Because I'm not a fan of memorizing stuff. Here's what I would do, honestly. I would just take a look at the answers, at the options they give me, distribute everything, and see which one matches. You know what I mean? You now know that the difference of cubes and the sum of cubes exists. So the next time you really need this in a class, look it up. Wikipedia it. But there's no real, I don't know. I honestly think there's no real, substance to memorizing this equation. You got to memorize it because there's no way you could ever look it up. That's why I never taught it to you. So in this context, just cube out everything, square out everything, I don't know, whatever you want to do. And then, multiply it out. So the option is D. And you can see the option as D because, look, this is the A times that junk minus B times that junk. That's the same as the formula that I gave you. You see it? Anyway, it's easier to just multiply it out. All right, there's one last thing I want you to know. So difference of squares, that's important. Here's the other one that I want you to know. A plus b squared is a squared plus b squared. You remember that one? What is BTTF? You guys came up with a little acronym for my boot to the face saying? Yeah, it's boot to the face. No, this is a squared plus 2ab plus b squared. There we go. And then a minus b squared, that's a squared minus 2ab plus b squared. And it really is just doing this thing, but just changing it to a negative b. That will change 2 times a times negative b just becomes negative 2ab. And then negative b squared just becomes positive b squared. So really, it's just this equation on top that's important. Got it? And hey, the fact that I've drilled BTTF into your head so many times, at least you guys didn't forget it. Got it? All right. I think, to be honest with you, I think that there's 3 equations I would make sure you go in and memorize. First is the BTTF equation. A plus b squared is a squared plus 2ab plus b squared. The next one is I would memorize that difference of squares equation. A squared minus b squared is equal to a plus b times a minus b, close parentheses. The last equation I would make sure you know is the quadratic equation. And what Sophia is saying is what she's saying is another good equation is to memorize this one, negative b over 2a. And what that means is if you have some kind of quadratic like 2x squared plus 3x minus 4 equals 0, then all you got to do is plug this in here and plug a and b into this equation, and this will give you the x coordinates of vertex. Honestly, you can memorize that if you want. I don't even recommend it. What I would do is if I wanted to find the x coordinate of my vertex, what I would do is I would just say, well, the quadratic equation will definitely give me the 2 x-intercepts. Right here and right here. And in order to find the x-coordinate of my vertex, I just average those two. I find the middle of that. Done. Now, this is way quicker. Way quicker. But I could easily screw this formula up. This way, I know the quadratic equation. And I bet you that the questions that they're going to ask is, hey, here's a formula. What is the x-coordinate of the vertex? What is the x-intercepts? What is the y-coordinate of the vertex? And all of that kind of stuff. And so if you're solving it this way, systematically, there we go. Why was there an A and why is there an A and an A minus B in front of the parentheses for the correct answer 38? Oh, okay. For question 38, the answer was this. A times A squared plus AB plus B squared minus B times A squared plus AB plus B squared. And Lucas, I think I caught you on this trick once before. So when you see it again, you're going to be like, oh, okay. All right. Here's what I would say. Let A squared plus AB plus B squared equal smiley face. Got it? Then I'm writing this down. This is A times smiley face minus B times smiley face. Right? Hey, there's a smiley face in both of them. So this is really just A minus B times smiley face, which is A minus B times A squared plus AB plus B squared. This is the equation I gave you. This is the equation they had. It's really the same thing. What I would do in your case is I would literally just distribute this A, distribute that negative B, and then see what kills each other. And I bet you what is going to end up being left in the dust, when the dust settles, is just A cubed minus B cubed. And notice how I played emphasis on that negative B. So you take negative B here, negative B here, and negative B here. There's a minus in front of all of these terms up there. We cool? All right.